Imagine sending a message to someone without wires, without touching anything, without even seeing how it travels. Yet in seconds, your video loads, your message is delivered, and your game connects to players across the world. This is the invisible magic of Wi-Fi. But it's not magic at all. It's science, and once you understand it, you'll never look at your phone or router the same way again. Let's start with a simple question. What is Wi-Fi? Wi-Fi is a way for devices to communicate wirelessly using radio waves. These are the same type of waves used by radios, TVs, and even some satellites. The only difference is how the data is encoded and transmitted. Now imagine this. You open your phone and click on a video. That simple action triggers a complex process. Your phone doesn't just get the video. It sends a request. But how does that request travel through the air? Inside your phone, everything starts as digital data. Digital data is just a series of ones and zeros. These ones and zeros represent everything: text, images, videos, sounds. When you tap something, your phone converts your action into binary code. But binary code cannot travel through the air on its own. So your phone needs a carrier. That carrier is a radio wave. Your phone has a tiny component called a transmitter. This transmitter takes the binary data and attaches it to a radio signal. This process is called modulation. Think of it like putting a message inside a moving wave. Now the radio wave is sent out into the air. These waves travel at the speed of light. Yes, the same speed as light itself. But here's something important. These waves don't go directly to the internet. First, they go to a device much closer to you, your Wi-Fi router. Your router is like a middleman. It listens for signals from your phone and responds to them. When your phone sends out a radio signal, the router receives it using its antenna. Inside the router, something incredible happens. The router decodes the radio signal. It removes the wave and extracts the original binary data. That data is your request, for example, a request to watch a video. Now the router sends this request to the internet. This usually happens through a wired connection like fiber or cable. The request travels across many servers until it reaches the destination, maybe a video server somewhere in another country. That server then sends the data back. But the journey back is just as complex. The data travels across the internet, reaches your router, and then your router converts it again into radio waves. These waves are broadcast into your room. Your phone picks up those waves using its receiver. It decodes them, turns them back into binary, and then into something you can see: a video, a message, or a web page. And all of this happens in milliseconds. Now let's go deeper. How does your phone know which signal is meant for it? In the air, there are many signals, from other phones, routers, Bluetooth devices, and more. If all signals mixed together, nothing would work. To solve this, each device has a unique address called a MAC address. When data is sent, it includes the destination address. Your phone only accepts data that matches its address. It's like receiving a letter. Even if many letters are flying around, you only open the one with your name on it. Another important concept is frequency. Wi-Fi doesn't use just one type of wave. It uses different frequency bands, mainly 2.4 GHz and 5 GHz. These numbers represent how fast the wave oscillates. Lower frequencies like 2.4 GHz can travel farther and pass through walls more easily. But they are slower and more crowded. Higher frequencies like 5 GHz are faster but don't travel as far and struggle with obstacles like walls. Modern routers can switch between these frequencies automatically to give you the best performance. Now let's talk about speed. Why is Wi-Fi sometimes fast and sometimes slow? There are several reasons. First is distance. The farther you are from the router, the weaker the signal becomes. Second is interference. Other devices like microwaves, Bluetooth, and even other Wi-Fi networks can interfere with your signal. Third is bandwidth. If many devices are connected to the same router, they all share the connection. This can slow things down. To improve this, modern Wi-Fi uses advanced technologies like MIMO, which stands for Multiple Input Multiple Output. This allows routers to send multiple data streams at the same time. There's also beamforming. Instead of sending signals in all directions, the router can focus the signal directly toward your device, making it stronger and faster. Now here's something fascinating. Even though you can't see Wi-Fi, it fills the entire room. Right now, you are surrounded by invisible waves carrying information. Every message, every video, every notification is moving through the air around you constantly. It's like an invisible highway of data. But is it safe? Wi-Fi signals are a form of non-ionizing radiation. This means they don't have enough energy to damage your DNA. They are considered safe for everyday use. However, security is a different story. Because Wi-Fi signals travel through the air, they can potentially be intercepted. That's why encryption is used. When you connect to a secure network, your data is encrypted before being sent. This means even if someone captures the signal, they cannot understand it without the key. This is what keeps your passwords, messages, and personal data safe. Now think about this. Every time you connect to Wi-Fi, you are part of a global system. Your small action, opening an app, triggers a chain of events involving devices, routers, servers, and satellites across the world. All happening instantly. All invisible. All powered by physics, engineering, and code. So the next time your video loads or your message sends, remember this. Your device is not just using internet. It is speaking a complex language of waves, signals, and data.